Welcome dear students to another video about number system. My name is Sharjeel. If this is your first time here and you wanna learn math from very basic, so starts now by subscribing and clicking bell button so that you don't miss anything. Dear students, in the very beginning, human life was very simple. For example, an herdsman compared his herds with a pile of stones while sending his herds for grazing and on its return for the missing animals. Some of them used vertical strokes for counting. For example, 1, 2, 3. Dear students, early counting system was dependent only on the natural numbers, which is from 1 to infinity. For further ancient number system example, dear students, please watch the information part in that suggested video. Link is showing on the screen. Students, as I said, the early number system was belong to natural numbers, which is from 1 to infinity. But as math get advanced, we needed some more sets. For example, if I write equation x plus 2 equal to 2, its solution is 0, which does not belong to natural numbers. So we have introduced another number set, which is whole number set. Whole number set starts from 0 and goes up to infinity. If I talk about the equation x plus 3 equal to 1, the solution of this equation is minus 2, which does not belongs to the whole number set. So another set is introduced, which is integer set. Integer starts from minus infinity and goes up to infinity. They includes all the negative numbers and all the positive numbers. Students, remember, if you are asked to write the positive integers, then write the integers from positive 1 to positive infinity. If you are asked to write the negative integers, then write the integers from minus 1 to minus infinity. And if you ask to write integers only, so include the 0 in the positive and the negative integers and write the integer set from minus infinity to infinity. Students, if I write example 2x equal to 5, the solution of this equation is 5 over 2. The fractional answer, this number is not present in the integer set, so another set is introduced, which is rational number set. I will talk about rational number later in this video. If I write equation x square equal to 3, the answer or the solution of this equation is plus minus under root 3, which does not belong to the rational number set. So another set is introduced, which is irrational set. Students, look carefully all the sets. You will see the set starting from natural number, and if we add 0 in the natural number set, the set extends to whole number. If I add the negative numbers in the whole number set, the set extends to integer set. And if I add all the fractional numbers in the integer set, the set extends to rational number set. But the irrational number set is independent. So dear students, combining the rational and irrational number sets, and other set formed, which is real number set. So real number contains all the rational numbers and all the irrational numbers. Now we will see what are rational numbers and what are irrational numbers. Rational numbers are those numbers which can be written in the form of p by q, where p and q are integers and q cannot be equal to 0. Take some examples. For example, if I write 2 by 3 here, 2 is integer, 3 is integer, and 3 not equal to 0. So yes, this is a rational number. If I take example 0 by 3 here, 0 is integer, 3 is integer, and 3 not equal to 0. Yes, this is also a rational number. If I take example 3 by 0 here, 3 is integer, 0 is integer, but 0 is equal to 0. The denominator is 0. So this is not a rational number. If I take example 5, 5 can be written as 5 by 1. Here 5 and 1 both are integers and 1 not equal to 0, q not equal to 0. So yes, this is also an rational number. Irrational numbers are those numbers which cannot be written in the form of p by q, where p is integer, q is integer, and q not equal to 0. For examples, under root 2, I can write under root 2 as under root 2 by 1 here. Under root 2 is not integer, but 1 is integer. So this is irrational number because p and q both are not integer. If I write under root 3, it is also an irrational number. If I write pi, it is also an irrational number because pi can be written as pi by 1. Q is integer but p is not integer. So this is irrational number. Students, now we will see how to find out the rational and irrational numbers from decimal representation. Dear students, rational numbers are those numbers which are terminating or recurring. Recurring means repeating. For example, if you have a number 20.03, you can see it is terminating after 2 decimal digits. So it is rational number. If I take example 0.400020, it is terminating after 6 decimal digits. So it is also a rational number. If I write 0.333, which is not terminating, then it will also be a rational number because it is recurring, means it is repeating digits. If I write 1 by 7, which is equal to 0.14287, you can see this number is not terminating, but the digits 14287 is repeating itself again and again. So it is also a rational number. Again, note that rational numbers are those numbers which are terminated or recurring. Students, the numbers which is neither terminating nor recurring are irrational numbers. For example, the number 2.312343 is irrational number because it is neither terminating nor recurring. If I write the number pi is equal to 3.141592 and onwards. The decimal digits of pi neither terminates nor repeated, so it is also an irrational number. Dear students, pi is an important irrational number which is the ratio of circumference of the circle and the diameter of the circle. Dear students, please spread this knowledge with your friends and family. Stay blessed. See you next time. Thank you.